Hello, math fans. Welcome back. Today we're doing synthetic division, which is the same thing as long division, except it's more efficient and easier. We're going to go straight to the example 1, and we're just going to perform the long division of that example. So what you have right now is 2x to the power 3 minus 5x squared minus 8x plus 15, and we're going to divide that by x minus 3. So first thing we're going to do is we're going to set it up. So 2x to the power 3 minus 5x squared minus 8x plus 15. And we're going to divide that by x minus 3. So if you remember from the last time you watched this, you ask yourself, how many times does x go into 2x to the power 3? Now, if you're not sure on how to get that number, what you can simply do is just take 2x to the power 3 and divide it by x. So if you do exponent division, if you remember from grade 11, 2 is going to be 2 divided by 1, which is just going to give you 2, and x to the power 3 divided by x is just going to produce x squared. So the number that you're looking for is 2x squared, and we're going to place that just above negative 5x squared, and we're going to perform our multiplication. So we're going to take the 2x squared and we're going to multiply it with the binomial, with each term. So 2x squared times x will produce 2x to the power 3, and 2x squared times negative 3 will produce negative 6x squared. The next step is subtraction. So we're going to take 2x to the power 3 minus 2x to the power 3. That will give us a 0. And then negative 5x squared minus negative 6x will give us a positive 1x, or just plus x squared. So we usually don't write the 1 coefficient. The next step is that we're going to drop the negative 8x, and we're going to repeat the process. So how many times does x go into x squared now? And the answer is x times. So we're going to put x here at the top, and we're going to perform our multiplication. So we're going to take x and multiply with every term in this binomial. So x times x will produce x squared, and x times negative 3 will give us negative 3x. And we subtract once again. X squared minus x squared will just give us a 0, and negative 8x minus negative 3x, which is negative 8x plus 3x, will give us a negative 5x. And then we are going to drop 15. So we're going to write 15 plus 15. And we're going to ask ourselves, how many times does x go into negative 5x? And the answer would be negative 5 times. And we're going to perform the multiplication for the last time. So negative 5 times x will give us negative 5x, and negative 5 times negative 3 will give us a positive 15, which is exactly what we have above. So if we were to subtract, negative 5x minus negative 5x is actually negative 5x plus 5x, which gives us a 0. And 15 minus positive 15 will also give us a 0. So really what we have is a remainder of 0. So the answer for this division, I'm just going to erase these arrows at the top so we can see our original question, is 2x to the power 3 minus 5x squared minus 8x plus 15 divided by x minus 3 is 2x squared plus x minus 5. With 0 remainder, so we don't have to write anything. Now we're going to perform the same division, but only using synthetic division. So if we go back up, we have a few steps there, A, B, C, D, and E. But before we actually begin the steps, we have to set up our synthetic division. So how we're going to do that is by looking at the coefficients of the dividend. So if you look at our dividend here, you have 2x to the power of 3 minus 5x squared minus 8x plus 15. We're just going to take out the coefficients and we're going to write them out. So we're going to write 2. We're going to write negative 5, negative 8, and 15. Those are the numbers that are of interest to us. And then we're going to draw something like a weird shaped L and another vertical line just at the end. The next number that we need is the restriction to x minus 3. So how we're going to get the restriction is we're going to make it equal, well, we're going to make it not equal to 0 because we're looking for a restriction, and then we're going to move negative 3 over, which is going to give us a restriction of positive 3. And that is what we're going to place to the left of this vertical line. That is the number we're going to be dealing with when we're performing synthetic division. So this is the general setup. First you write out the coefficients, then you find a restriction, and that is all we need. Then we can actually go back up to step A and start performing synthetic division. So as you see in step A, it says to bring down the first coefficient. So in this case, our first coefficient is 2, and we're just going to bring it down and rewrite it under the horizontal line. The second step is to multiply the restriction, which is 3 in this case, with the coefficient that we just brought down, and we're going to write the result below the second coefficient. So that means we're going to take the 3 times the 2, and we're going to write the result over here. So 3 times 2 is 6, and we're going to write it just under here. The last step is to add these two numbers, so negative 5 and 6. So negative 5 plus 6 will give us just 1. And that is the full cycle which we are going to repeat from now on. So we're going to take our restriction, which is 3, we're going to multiply it with 1, and we're going to write the result under negative 8. So 3 times 1 is 3, and we're going to write it just under negative 8. And we're going to add again. So negative 8 plus 3 will give us a negative 5. So far so good. And we're going to repeat this cycle one more time. So we're going to take the restriction, which is 3, and multiply it with negative 5. And we're going to write the result under the 15. So 3 times negative 5 will give us a negative 15, which works out really well because if we add 15 and negative 15, we get a 0. And as you can see, this last slot with this vertical line actually represents a remainder. So in this case, we get a remainder of 0, which is the same as the remainder in the long division here. So how do we pull out the answer? Well, the numbers that we got is 2, 1, and negative 5. They are coefficients. So just like we pulled out the coefficients originally to set up synthetic division, now we have to take these coefficients and transform them back into our trinomial. So how it works is that starting on the first right number, which is a negative 5 here, that number represents our constant, which is negative 5. As you move to the left, the first number, which is 1 in this case, represents x to the power of 1. So what it really is 1x to the power of 1. The next number over represents x to the power of 2. So in this case, it's 2x to the power of 2. So we're just placing the coefficient in front of the corresponding variable and the exponent. If we had more numbers to the left of 2, we would just keep going and increasing the exponent. So we would have x to the power of 3, x to the power of 4, and so on. But we only have a trinomial, so essentially this trinomial is 2x squared plus x, because we don't have to write all those coefficients and exponents, minus 5. And that would be the answer to this synthetic division, which is exactly what we got in the long division. And we can write the answer two different ways. So I'm going to use a different color here. So 2x to the power of 3 minus 5x squared minus 8x plus 15 is equal to x minus 3 times 2x squared plus x minus 5. Since we didn't get any remainder, that means that both of these, x minus 3 and 2x squared plus x minus 5, are factors of our original big polynomial. Now another way we can write this in our division statement is 2x to the power of 3 minus 5x squared minus 8x plus 15 over x minus 3 is 2x squared plus x minus 5. Both are valid. We're going to use the first one mainly because we're going to be factoring polynomials in the future for the purpose of graphing. So that one's going to be more practical, but you do need to know the second one as well. So that is pretty much the process of synthetic division. We are going to do another example, which is a little bit more complex. So we can just set it up as a synthetic division. We're going to look at the coefficients of our large polynomials. So in this case we have 12, 2, 11, and 16. So we're just going to write them out as 12, 2, 11, and 16. And that weird shaped L with a vertical line at the end for our remainder. That's the remainder slot. And now we need the restriction. So restriction to the 3x plus 2, we're going to cannot be equal to 0, and we're going to isolate x. So we're going to move 2 over, which is going to be 3x cannot be equal to negative 2, and then we're going to divide everything by 3, which is going to produce a restriction of negative 2 over 3. That is the number we're going to put to the left of the vertical line here. And now we can actually start performing the synthetic division. So if you remember that the first step is to drop the first coefficient down and rewrite it. In this case it's 12. And then the next step is to multiply the restriction with that first coefficient and to write the result under the next coefficient. In this case it's 2. So what we have to look at is negative 2 over 3 times 12. Now if you can't do it in your head, just write it on the side. Negative 2 over 3 times 12 over 1. And the answer to this is negative 8 if you actually do the division at the end. And we're going to write negative 8 on the side under the second coefficient, which in this case is 2. The next step is to add 2 plus negative 8, and that will produce a negative 6. At this point we're going to restart our synthetic cycle. So in this case we're going to take negative 2 over 3, and I can write it on the side here, negative 2 over 3 times negative 6 over 1. I'm putting it in fraction form if it helps you multiply and reduce. So negative and a negative will give you a positive answer in the end, and you have 2 times 6, which is 12 over 3, which actually reduces to 4. And that is the value we're going to put under our next coefficient. And then we're simply going to add them. 11 plus 4 will give you 15. And one more time, we're going to perform the multiplication. So we're going to have negative 2 over 3 times 15 over 1. And you're going to get a negative answer because negative to positive gives you negative. 2 times 15 will give you 30. And 3 times 1 will give you 3. And if you reduce this, or just divide simply, it's going to be negative 10. And that is the number we're going to write here. And one more time, we're going to add. So 16 plus negative 10 will just give us 6. So in this case, we didn't get a 0, which means we have a remainder of 6. And that's okay because we're not really fully factoring these polynomials. We're just performing synthetic division, so it's okay to get a remainder. Now to extract the answer, So in this case, I'm just going to write a division statement. Just a little further. So we have 12 x to the power 3 plus 2x squared plus 11x plus 16. And that is going to be equal to, I'm going to run out of space, so I'm just going to erase these on the side. So that is definitely going to be equal to 12x squared minus 6x plus 15. And just a reminder, we got these from the coefficients over here. So the first number, 15, is our constant. Second number is negative 6 to the power of x. And then the next number is 12x squared. And you can keep going, but in this case we only have 3 terms. We have a remainder of 6, so we can add that at the end. Now in our division, we actually used x plus 2 over 3. Because if you look back up here, we used the negative 2 over 3, so if you put it back into that factored form, it's going to be x plus 2 over 3, which is not really what the question was about. Originally the question was to divide with 3x plus 2. So what we have to do in this type of question is we're going to adjust this factor by using some other values. If you look at our answer, so 12x squared minus 6x plus 15, they actually have a common factor. So I'm just going to copy x plus 2 over 3, and I'm going to factor out 3 out of 12x squared minus 6x, plus 15. So if I factor out 3, I'm going to get 4x squared minus 2x plus 5. And plus 6 at the end. And we're going to use that 3 in our binomial. So we're going to take the 3 and we're going to multiply with every term inside the bracket. So we're going to have x times 3, which is going to give us 3x. And we're going to have 2 over 3 times 3, which is going to give us plus 2. We can rewrite the rest. And that would be your final division statement. So the answer to the question of 12x to the power of 3 plus 2x squared plus 11x plus 16 divided by 3x plus 2 is 4x squared minus 2x plus 5 with a remainder of 6. That wraps up our synthetic division. Now there's a few questions on page 35, number 3 and 7. Some of the questions ask specifically for synthetic division, but I suggest you try long division as well just to practice. And I will also leave a handout for extra practice. Now we were supposed to have, I was going to give you a quiz on long division and synthetic division on Thursday, but I think I will move it to Friday because I can see you Thursday and clarify any other issues that you might have with long division and synthetic division. That's it. Merovac out.